Guys, how are we doing today? We are going to be moving on into day 2 of our acid-base calculation notes. So we're going to be talking about more of that pH, pOH, the hydroxide concentration, and the hydrogen concentration. Um, so there are two big formulas, like Ms. Tree said in day 1, that we cover with our acid-base calculations. The first one that we use is our negative log. Negative log is going to be used to convert from a concentration to a power, okay? And that concentration to that power, okay? So what that means is that if I've got a hydrogen concentration, then the negative log formula tells me the power of hydrogen, the pH. If I've got a hydroxide concentration, on the other hand, it's going to tell me the power of hydroxide, okay? So the pOH, all right? The other formula that we have is the 1 times 10 to the negative 14 equals our hydrogen concentration times our hydroxide concentration. So we should be able to multiply those two concentrations together to get 1 times 10 to the negative 14, okay? So we're going to actually go ahead and dive on into this. So in this first one, what we're going to start and focus on is converting hydroxide concentration to the power of hydroxide, the pOH. Okay, so how do I do that? Well, I use this formula here. So pOH equals the negative log of our hydroxide concentration. So here my first question is, what is the pOH of the following? Okay, so we're going to start with one that's a little bit easier. So I have a hydroxide concentration here, and they want to know what is the pOH of this concentration. So I know that pOH equals the negative log of 1 times 10 to the negative 9. Okay, I'm going to solve that. I'm going to type it into my calculator, and when I do, I'm going to end up with 9. Okay, now one thing I do want y'all to notice is this right here. If you've got 1 in the front of that, then you can use this superscript as your power, okay? Now again, remember, this is going to be doing our power of whatever our concentration actually is, okay? So that's what we're going to be solving for with one of these types of problems, okay? So here's another one. Now if you notice, first off, we do have a hydroxide concentration, so when we do the negative log, that's going to give me the power of hydroxide, which is good because that's what my question's asking for. Another thing to notice is that this number right here is not 1, okay? If it was 1, we could just use that superscript, but it's not. So we have to do our negative log formula. So the pOH equals negative log of 9.98 times 10 to the negative 3. Okay, you're going to plug that in your calculator, negative log. Okay, and if you've got a TI-83, the log button is over there on the left side of your calculator. It is right beside the number 7. So you're going to plug that into your calculator, and you should end up with 2 as your answer. Okay, so your pOH would be 2 there. All right, now, before I do this next one, let's slide on over to this other side of the page, okay? Now, one thing I want y'all to remember is that if I'm talking about a strong acid or a strong base, they are going to completely dissociate. So they're going to separate into their ions, okay? And so if I've got, for instance, this sodium hydroxide here, there's 2 ions there. There's the sodium ion and there's the hydroxide ion. Okay, so all of those would have a concentration of 2M, 2 molarity. Okay, on the other hand, if I've got this barium hydroxide here, which has a concentration of 2M, it's going to separate into 1 barium and 2 hydroxide. Now, what that's going to tell you is that you're going to have to remember to multiply that concentration by 2. Okay, so that's something to keep in mind when you're doing this. Okay, is if you've got more than one of our hydroxide or even our hydrogen, if we're talking about an acid, you're going to have to keep that in mind when you're looking at these, okay? So the rest of these are just kind of duplicates of that above. Hydrochloric, it had a concentration of 2M. Okay, so when we separated that out, when we dissociated it, we have a hydrogen ion and a chlorine ion. Both of those have a concentration of 2M. Okay, now this one's a little bit more tricky. This has to do with some of our acid-base rules that we don't really talk about in pre-AP. But one thing that acids do is they don't always dissociate completely into what you would think of as like two hydrogens and one sulfate. Acids actually separate into, they pull off one hydrogen at a time, okay? And so what we do is we pulled off one hydrogen, which means we're still left with one hydrogen on that, okay? Now, y'all aren't going to need to know this for pre-AP, but it is something that I did want to mention to y'all for the future, okay? All right, so let's come back and let's look at this one. So right here, I have calcium hydroxide, and they say that its concentration is 8.17 times 10 to the negative 8. Okay, again, I'm looking for my pOH. Remember, pOH is equal to the negative log of that concentration. So I'm just going to actually put that there. All right. So the pOH is equal to the negative log of the concentration. Before we actually solve this, we do have to remember to dissociate this. Okay, so calcium is going to form one ion, and hydroxide is going to have two ions. Okay, so that's going to tell me that I'm going to need to multiply my concentration of hydroxide by 2. Okay, so I'm going to take that. I've got 8.17 times 10 to the negative 8, and I'm going to multiply that by 2, and that's going to give me 1.63 times 10 to the negative 7. Okay, so it does change your concentration, and you do need to keep that in mind when you're solving this. Well, now I can take this number and actually plug it in. So pOH equals the negative log of 1.63 times 10 to the negative 7. Okay, I'm going to plug that into my calculator, and I'm going to end up with 6.79. All right. That's how you would solve for a power of hydroxide, the pOH, if you're given the hydroxide concentration. Now, let's flip that around. So let's say I wanted to go from the power of hydroxide into the concentration of hydroxide. Okay, well, our formula is going to be what you see right here. Hydroxide concentration equals 10 to the power of the negative pOH. Okay, so 10 to the power of the negative pOH. So right here, what is my hydroxide concentration of each of the following? Hydroxide concentration equals 10 to the power of the negative pOH. So right here, my pOH is 10.6. So negative 10.6. Okay, I'm going to plug that into my calculator, and I will end up with a hydroxide concentration of 2.51 times 10 to the negative 11. Okay, moving on. Here I've got B. So for B, again, same scenario. I'm trying to find the hydroxide concentration. I'm given the power. So I will do my hydroxide concentration equals 10 to the power of the negative pOH, which in this case is 2.3. Okay, again, I'll plug that into my calculator, and I'll find that that gives me 5.0 times 10 to the negative 3. So that would be my hydroxide concentration. Okay, now again, with concentration, molarity would be our unit. Okay. Now, let's say I wanted to go from pH to POH or from POH to pH. Now, this is actually the easiest. And this is technically going to have a formula, but that formula is this basic thing right here. pH plus POH equals 14. Okay. Remember, our scale for pH goes from 1 to 14. So there's 14 numbers there. Okay. So what is the POH of the following? pH equals 4. Okay, well, if I'm looking for POH, I'm going to do 14 minus 4. So a POH equals 10. Okay, it is that easy. All right, just a very simple subtraction. Okay, same thing here. If I'm solving for my POH, 14 minus the pH, 2.9, I'm going to find my POH to equal 11.1. Okay. Now, pH and POH do not have units, so you don't need to put that unit there. Okay. Well, what if they're asking for pH? Same thing. So if I'm looking for pH, it's going to equal 14 minus the POH, 6.3. So my pH here would equal 7.7. Okay, right here, POH is 8.4. So if I'm solving for pH, 14 minus 8.4, so my pH is going to give me 5.6. Okay? All right. So those would be the easiest types that you can find if you're just doing a direct conversion of like pH to POH or in the other direction. Okay. This table breaks it all down. Okay. So let's say I'm trying to go from a hydrogen concentration to the power of hydrogen. Again, if I'm going in this direction, I'm going to be using this formula. Okay, so pH equals the negative log of that concentration. This also shows you, though, if you're trying to go from like a hydrogen concentration to the power of hydroxide, you could go from our hydrogen concentration, just like we did, to our power of hydrogen, and then we could go across and subtract, or you could go from our hydrogen concentration to our hydroxide concentration and then do the negative log to get to our POH. Okay? Either one is okay, but you can't go directly from a hydrogen concentration to a power of hydroxide. Okay? They're two different things. So you're going to have to make two conversions if you notice those do not line up. Okay? So here's some practices on that, some of those multi-step conversions. So my question here is, what is the pH of 5.45 times 10 to the negative 4 molar KOH? So I'm looking for my pH, okay? pH, we'll just table again and double check how to go from OH to pH. Okay, so I'm trying to go from our OH to our pH. So there's two different ways that we can do this. I'm going to work through both of them just to make sure you know how to do both of them. But it is going to take 2 steps. I can either go down to POH and then across to pH, or I could go across to hydrogen concentration and down to our pH. Okay, either one of those would be okay to do. So how do I do that? Okay, so what is the pH? Well, right now I'm in our hydroxide concentration. Okay, so I'm in the hydroxide concentration. So my personal favorite way to do this is to go from our concentration to the power. Okay, so if I'm going from the concentration to the power, I'm going to have to go to whatever power matches up with what I've got. Here, I've got the concentration of hydroxide, so I'm going to have to go to the power of hydroxide. So I'll do the negative log of that. So my POH, my power of hydroxide, is negative log 5.45 times 10 to the negative 4. Okay, I'm going to solve that, and that's actually going to give me 3.26. So my POH is 3.26. Well, I'm looking for my pH, and pH is equal to 14 minus my POH. Well, I found my POH to be 3.26. Okay, so 14 minus 3.26, that tells me that my pH is going to be 10.7. Okay, so what if I were to do it the other way? So I'm going to write or. I had my concentration of 5.45 times 10 to the negative 4 as that concentration. And again, this is the hydroxide concentration, right? So first thing that I would need to do if I'm doing this in the other way is to go from hydroxide concentration to hydrogen concentration. So my hydrogen concentration equals 1 times 10 to the negative 14 over 5.45 times 10 to the negative 4. Okay, I'm going to solve that, and I'm going to find that my hydrogen concentration equals 1.83 times 10 to the negative 11. Okay, now if I'm looking for pH, now I'm in the right concentration. So now I would do pH equals negative log of 1.83 times 10 to the negative 11. Okay, I'm going to solve that, and I will find that my pH equals, again, 10.7. Okay, now if you notice, those numbers do match up, and they are pretty much perfectly the same when you type it in your calculator. So either way is okay. I, again, personally like the first way because it is just a matter of subtracting after you do that first problem, okay, the first part of that problem. All right, so again, I'm going to keep on doing both ways of this to make sure you know how to do both ways. So what is the POH of 3.67 times 10 to the negative 13 molar HCl? Okay, well, this concentration is a hydrogen concentration. So I am not matching up here. This is power of hydroxide. This is hydrogen concentration. So they don't match up. Okay, if they don't match up, it's going to be 2 steps. So 2 different ways you can do this. Again, I will do the way that I think is the faster way, the easier way, but we'll do both. So first off, we would solve for our pH. Okay, so pH equals the negative log of our hydrogen concentration. So pH equals the negative log of 3.67 times 10 to the negative 13. Okay, I'm going to plug that into my calculator, and I will find that that gives me 12.4 as our pH. Okay, well, now I need to look for the POH. So POH equals 14 minus 12.4. So my POH equals 1.6. Okay? Or you could do this in this other way. So I have a hydrogen concentration of 3.67 times 10 to the negative 13. Okay, now I'm going to go to the hydroxide concentration. So OH equals 1 times 10 to the negative 14 over 3.67 times 10 to the negative 13. I'll plug that into my calculator, and what I'll end up with is 2.72 times 10 to the negative 2. All right. Well, my question is not asking for hydroxide concentration. It's asking for the power of hydroxide. So, power of hydroxide equals the negative log of that hydroxide concentration, 2.72 times 10 to the negative 2. So my POH, it's going to end up giving you the answer of 1.57. Okay, now those numbers are not exactly the same, right? But they are within 3/100ths of each other, which is very, very close. Okay, so again, either way is acceptable. If you're given a multiple choice problem, then obviously pick the one that's closest to your answer. Depending on the way that I solve the problem when we're making those problems, determines what answer you're going to see on there. Okay. All right. So next, what is the hydroxide concentration of magnesium hydroxide with a pH of 10.3? Okay. So I've got pH and OH. Those don't match up. So again, I know that's a two-step problem. So first off, my preferred way to do this one is to go to our POH, because again, that's just subtracting, right? So if I go to POH, that's going to be 14 minus 10.3. Okay, so my POH is going to equal 3.7. Okay, well now I can convert that into our hydroxide concentration. So hydroxide concentration is 10 to the power of negative 3.7. Okay, plug that into my calculator and I will end up with 2.00 times 10 to the negative 4 molarity. Okay. Or you could do my pH. I have a pH of 10.3, and I could go to our hydrogen concentration. Okay, and I would do that with 10 to the power of the pH, negative 10.3. So 10 to the power of negative 10.3. And what that would give me would be a hydrogen concentration of 5.01 times 10 to the negative 11. Okay, well now I've got my hydrogen concentration, but I need my hydroxide concentration. So our hydroxide concentration equals 1 times 10 to the negative 14 divided by 5.01 times 10 to the negative 11. So my hydroxide concentration is equal to 2.00 times 10 to the negative 4 molarity. Again, that came from our calculator. They are the exact same numbers. Okay, they should always be very, very, very close. Okay. All right, I'm going to do one more. So, what is the hydrogen concentration of lithium hydroxide with a POH of 1.32? Okay, so I've got a POH of 1.32. This is hydroxide. This is hydrogen. They don't match up, so it is two steps. So I'm going to have to convert. So first off, I like to go from POH into pH because it's easier. So if I'm looking for my pH, 14 minus that POH, 1.32. So my pH is going to equal 12.68. Okay. Now, I would need to make a conversion. So I've got a pH of 12.68. I'm looking for my hydrogen concentration. So remember, our formula to go from our power to our concentration is 10 to the power of the negative pH. Okay, so here, 10 to the power of negative 12.68. Okay, and what I would find is that my hydrogen concentration is going to equal 2.09 times 10 to the negative 13 molarity. The other way to do this would be to go from our POH, so a POH was 1.32, and go to our hydroxide concentration. Okay? So go to OH minus, and that equals 10 to the power of negative 1.32. I plug that in my calculator, and I will find that my hydroxide concentration is going to equal 4.79 times 10 to the negative 2. Okay. But I'm looking for my hydrogen concentration. So hydrogen concentration equals 1 times 10 to the negative 14 divided by our hydroxide concentration, 4.79 times 10 to the negative 2. Okay, plug that in the calculator, and I'll find my hydrogen concentration equals 2.09 times 10 to the negative 13 molarity. And again, those do match up. Okay, that is it. Now you know how to do all of the acid-base calculations. If y'all have any questions, please don't hesitate to contact Miss Treese or I. And we are missing y'all, and we are hoping to get back to see y'all soon.